Welcome to BTech Revision. In today's lesson, we're looking at power. By the end, we should be able to calculate power, current, and voltage in circuits. What is power? Power is the energy transferred in a unit of time, and electrical power can be given by this equation below. Current times voltage. The units we can use are for current is amps, voltage is measured in volts, and power is measured in watts. And if you remember from a previous lesson, voltage can be given by V equals I times R. So we can replace voltage with I and R, which gives us the second equation, power equals current squared times resistance. And if you remember, the unit for resistance is ohms. The unit for current here is amps. And since it's squared, we have to square that. And power is going to be watts again. Now, let's look at an example. An electric oven has a power of 2 kilowatts. A. Calculate the current when the main supply is 230 volts. So we can start by writing down our equations. Power equals IV and power equals I squared times R. For this case, we have power, but it's in the wrong form. We want to get rid of the prefix there. So that's 2. K stands for 1,000, so that's 2,000 watts. Power equals 2,000. And we have the voltage. Okay, so all we need to do is rearrange the equation, I, which is equal to power divided by volts. Power is 2,000. And voltage is 230. So 2,000 divided by 230 gives us a value of 8.70 amps. For the second question, calculate the resistance in the oven. So we'll assume the power remains the same. Is power taken from question part A, so that's 2,000 watts. And we want to calculate the resistance, so we need the second equation here. So power equals I squared times R. So rearranging for resistance equals power divided by I squared. So that would be 2,000 divided by, and we'll assume the same current. So current is 8.7. That would be squared here. And this will give us a value of 26.45 ohms. Now pause the video here and attempt this exam question. Question 1. A 3-volt potential difference is across a LED and has a current of 3 milliamps flowing through it. Calculate the power of the LED. You can start by writing down an equation. Power equals current times voltage. And we know our current is 3 milliamps, so we can convert that. So that's 3 times 10 to the power minus 3. And the voltage is 3 volts, so times 3. And that's equal to 9 times 10 to the power minus 3. And that would be watts. For part B, the potential difference is increased to 5 volts and the resistance of the LED is 5 ohms. Calculate the current flowing through the LED. We can start by writing down our second equation. So we know power equals I squared R. And since it's asking for current, we can rearrange for I, which is equal to I squared equals power divided by R. So therefore, I equals square root power divided by R. And we can plug in the values. We have the power of the LED should remain the same. That will be 9 times 10 to the power minus 3. And the resistance here, it mentions is 5. So we can work this out. 9 times 10 to the power minus 3 divided by 5 square root of our answer to give us a value of 0.0424 amps. And that's the end of the lesson. If you would like to boost your grades, visit us at btechrevision.com where there's lots of quiz questions and more resources. See you next lesson.